You know, every single star you see in the night sky is locked in this epic, constant battle, a tug of war between gravity trying to crush it and nuclear fusion trying to blow it apart. But that fight can't go on forever. So what actually happens when a star finally runs out of gas? Well, today we're diving into the magnificent and sometimes unbelievably violent ways that stars die. Let's go witness the last breath of a star. For billions and billions of years, a star just shines, holding steady in this perfect, delicate balance. Well, this whole explainer is about what happens when that cosmic breath is finally and inevitably let go. All right, so to understand how a star dies, we first have to get a handle on how it lives. And really, it all comes down to one fundamental principle, this cosmic balancing act that defines its entire life. This right here, hydrostatic equilibrium, this is the truce that keeps a star stable. You've got gravity, which is relentlessly trying to crush the star into the tiniest ball imaginable. At the same time, you've got this nuclear furnace in its core that's constantly pushing outward. For most of a star's life, these two forces are in a perfect, delicate stalemate. It's basically a cosmic tug of war, right? Gravity pulls in, fusion pushes out. And that balance is what lets a star shine so steadily for eons. But, and this is the whole key, the fuel for that fusion isn't infinite. And when it starts to run out, well, that's when gravity starts to get the upper hand. So what happens when that fuel starts to sputter out? Well, it turns out the script for a star's final act is written by just one thing, its mass. Mass dictates everything. How hot it burns, how fast it lives, and, most importantly, whether its end will be a quiet, gentle fade or a truly cataclysmic bang. Okay, so first up, let's look at the path taken by the majority of stars out there, including our very own sun. This is the story of a relatively peaceful, though still incredibly grand goodbye. So, as the hydrogen fuel in the core gets used up, the star starts to swell up, bloating into this massive red giant. Eventually, this huge, puffy star just can't hang on to its outer layers anymore. It kind of gently shrugs them off into space, creating one of the most beautiful things in the entire universe. And this is what you get, a planetary nebula. Now, the name's a little misleading. They have absolutely nothing to do with planets. Early astronomers just thought they looked kind of like them through their dinky telescopes. What you're really seeing is physics made visible. These things are both an autopsy, showing us all the elements that were forged inside, and a bequest, seeding the cosmos with lighter elements like carbon, the building blocks for new worlds. But for the real heavyweights of the universe, stars more than 8 times the mass of our sun, the end is anything but gentle. No, their lives are short and furious, and their deaths are, without a doubt, the most spectacular fireworks show in the cosmos. You see, these massive stars forge heavier and heavier elements in these concentric shells, kind of like a cosmic Russian doll. Hydrogen fuses into helium in the outer layers, helium to carbon deeper in, and so on, all the way down to iron, right at the very center. But here's the problem. Iron is a total dead end. Fusing iron doesn't release energy, it actually consumes it. And this is where things get absolutely insane. Just look at this timeline. The final stages of fusion happen at a terrifying pace. It burns through carbon in a few centuries. Oxygen, 6 months. It fuses all its silicon in about a day. And once that iron core forms, the outward push from fusion just stops, and gravity wins. Instantly. We're talking less than a second. The core collapses on itself so fast and hard that it rebounds, sending a shockwave tearing through the rest of the star. And what you get is a supernova. An explosion so blindingly bright, it can actually outshine its entire home galaxy. It looks like the ultimate act of destruction, right? But what's really happening is an incredible act of creation. So, after all that sound and fury, after the fireworks are over, what's actually left behind? Well, these stellar endings leave behind some of the most extreme, most bizarre objects you can possibly imagine. Well, our 2 different paths leave behind 2 wildly different kinds of leftovers. A low-mass star, like our sun, leaves a white dwarf. It's basically the hot, dead core of the star, about the size of Earth, and it'll just slowly cool off for trillions of years. But the collapsed core of a massive star becomes a neutron star, an object maybe the size of a city, but with more mass than our entire sun packed inside. Just to try and wrap your head around how dense a neutron star is, get this. One single teaspoon of neutron star stuff would have the same mass as Mount Everest. It's just mind-bogglingly dense. But then, for the absolute biggest, baddest stars in the cosmos, even the forces holding a neutron star together just aren't enough. Gravity wins completely, and the core collapses forever into a black hole, a point of infinite density from which nothing, not even light itself, can ever escape. Okay, so this all feels super cosmic and far away, right? Black holes, neutron stars. But here's the thing. The story of a star's death, that's our origin story too. This isn't just about what's happening out there, it's about why we're here right now. Think about it. Pretty much every single element heavier than hydrogen and helium was cooked up inside a star and then scattered across space when it died. The calcium in your bones, that came from the gentle fade of a low-mass star. The iron that's in your blood right now, born in the violent bang of a supernova. We are literally made of star endings. You see, a star's death isn't really an end. It's a critical part of this huge cosmic recycling program. It's how the universe enriches itself, creating all the raw materials needed for new stars, new planets, and eventually, new life. It really is an act of ruthless generosity. So when you look up at the night sky, you're not just seeing little points of light. You're looking at a cosmic family album. You're looking at the ancestors whose deaths gave us the very stuff of our existence. Their final breath is the reason we get to take our first. And in that glow, there are always new stories waiting to be read.